handout for you guys today. Just paper, pencil, notes. Back to normal. All right. Have you guys seen this notation before for composing functions with like the double parentheses or the open circle? Does this look familiar at all? No? Okay. So when we see, there's two different ways this can be written. We would read this f of g when I see that open circle, and you're going to see in this section, like when you guys are doing the homework, you're going to have some problems with an open circle, and that's composition. You're going to have some problems with a closed circle, and that's multiplication, and they are very different calculations. So open circle is composition, or you're going to see it like this with a double parentheses. Both of them I would read f of g of x. And both of these mean I am plugging a function into another function. Now, the way it's ordered in that example, it's actually written down here. It means you are plugging function g into function f. I personally like the double parentheses notation better because I think it's easier to see that g is inside of f in that notation. Sometimes you'll see an x there. Sometimes you'll see a number there. If we see an x there, it means we're just plugging a function into another one and getting a new function. Your answer is a new function. If there's a number there, we're plugging one number into the first function, that answer into the second function, and you're going to get an answer out. Okay, so a variable gives us a new function, a number gives us a solution that we're looking for. Okay, so first type of problem that we're going to do today are going to look like this. So I want you guys to write down function f and function g, and these could be any of our parent functions that we've talked about, right? So we can have, like, this is a linear and a quadratic, it might be a square root, it might be a fraction, those rational ones, it could be, we don't get too much into like the exponential or log ones, but and then we want to be able to read the notation. So the first one says f of g of 2, okay? So I can write it like that, or I prefer this. Whenever I am evaluating a composition, we are always going to kind of like use order of operations. We're going to work from the inside out with our parentheses. So when I see g of 2 on the inside, that's my first step. It just means plug 2 into g, and we know how to do that. It would look like 2 squared plus 4, and my answer would be 8. So now that g of 2, I can replace with an 8. I know what g of 2 is equal to. And now you can see the next thing we're going to do. We're going to do f of 8. So we're going to take function f, and we're going to plug 8 into it. So 5 times 8 minus 6, which is 40, minus 6, which is 34, and that's our final answer. So the steps of this, we're taking our number, plugging it into the first function, then we're taking that answer and plugging it into the next function. We work our way out here, okay? So let's try the next one. G of f of negative 5. Again, I like it with the double parentheses, like this. Okay. So what's going to be my first step? Plug what into what? Plug negative 5 into f, start on the inside there. So 5 times negative 5 minus 6, so that's negative 25 minus 6, so negative 31. So now I'm going to find g of negative 31. I'm taking that answer and plugging it in. This one you're going to need a calculator for because we're squaring it. It's negative 31 squared plus 4. So let's see. That is, oh, what is that going to give me? 961 is my guess, plus 4, so 965. Somebody type it in and check. Am I right? 965. Okay, final answer. Make sense? Questions so far? Okay. All right. Now you're going to see problems like you saw yesterday where there are a function on a graph. So instead of being able to plug this number into an equation, we're going to find the answer on the graph. Either way, remember when you have function notation, and again, I'm going to write it like this. A number inside the parentheses, we talked about this a couple sections ago, is an x. So you have an x, you're looking for the y that goes with it when you're evaluating always. So the first thing I'm going to do on this one, and then I'll let you try the other two on your own in a minute, I'm going to find g of -1. So I have to know which graph to look at first of all. G is the purple one. G of -1 tells me I use an x value of -1, and then I go up or down to function g. In this case, I would have to go up to 1 to get to function g. So g of -1 is equal to 1. That's the y value that goes with that x. Then I do it again, but this time I have an x value of 1, and I want to find the y that goes with it on function f. So my x is 1, that takes me there, and actually I'm at function f. I'm on the blue line. So my answer is 0. That's the y that goes with it. Okay, and then that would be your final answer. All right, so find a friend. See if you can do the next two. I'll give you a few minutes. Okay. Answers 0 and -1. If you got something wrong, first thing I'd probably look at is make sure you were looking at the right line. F or G, whatever it was asking for. And you're always using an X to get a Y for these. So you're going left and right, and then either how far up or down you have to go. Yes?
So the X value is not going after, like, when we figure out what F stands for, we just get rid of it.
Yes, so when you say F of -3 is 3 on the graph, it replaces that whole function notation. Yes. You've evaluated that piece. What questions do we have here? Okay, so if there's a number, that's what it would look like. If you have an equation, you plug the number in. If you have a graph, you find the value on the graph. Or in a table, you can find the value in the table that's given to you. Okay, so now let's look at what happens if there's not a number there. If we're just using an x and composing one function into another function, it's literally going to look like substitution, kind of like we did with our systems of equations a chapter ago, okay? And we're going to do this right in your notes, what function f and g are. Okay, here's function f and here's function g, and we're going to do it 4 different ways. F into g, g into f into f, and g into g. Okay, so you're going to need a little space for this one. All right, so the first thing I'm going to do is part A there, g of f. Sometimes they don't even put the little x there, okay? You just have to know that unless you're given a number, I like my double parentheses, it's going to be written like this. There's another way to see that notation, okay? What function's being plugged into what there? Is f inside g or is g inside f? Right, and so I think it's helpful to write that down. That's literally your instructions. You are going to plug function f into function g. So here's what that looks like. I'm going to take all of function f, and I'm going to put it into function g anywhere where there's a variable. If there's more than one variable, I have to plug it in more than one place. Function g only has one x. So I'm going to take that x out, and I'm going to put 2x squared plus 3x in its place. So that will look like 2 times 2x squared plus 3x minus 1. So we're putting it in parentheses just like we practiced with our systems when we plug something in. And then you simplify whatever you can. Here all I can do is distribute the 2 through. And that is my final answer. That is g of f. Okay, again, unless I have a number for x, we can't go any further than that. Right? Now let's look at part B. Part B says f of g. So I like to write it like this. What am I plugging into what? G into f. Okay, so I'm going to take function g, and I'm going to put it into function f anywhere there's a variable. Now here you have to be careful. because there's two variables in function f. So there's two places that we're going to plug that 2x minus 1 in. So it looks like the following. 2 times 2x minus 1 replaces the x, and it's squared, plus 3 times 2x minus 1. And then we simplify. If you have a parenthesis squared, what should you do? Expand it? FOIL? Yep. Distribute later. Okay, so right now I'm just going to FOIL. First term's 2x and 2x, give me 4x squared. Outside terms are negative 2x, inside terms are negative 2x, it's a negative 4x. Last term, positive 1. Okay, and I'm just going to bring everything else down. So all I did was FOIL. Then I can distribute. 8x squared minus 8x plus 2 plus 6x minus 3. And then here I do have some like terms we can put together. So final answer is 8x squared. Negative 8x and 6x give me negative 2x. 2 and negative 3 give me a negative 1. Final answer. All right, then it gets interesting. F of f. So this is the only type that I really don't think it makes it any better if you write it with the double parentheses. It's pretty obvious that you're only dealing with one function. You're plugging f into f. That's it, okay? So how do you plug a function into itself? What I'm going to do is I'm going to take function f, and I'm just going to take out the x's and leave a blank. Leave like a parentheses there, okay? So it's 2, and then I'll just put a parentheses where my x is squared, plus 3, and then another parentheses where my other x is. So I'm just leaving some room where my variable is, okay? Wherever there's an x, what are we plugging in? We're plugging f into f. So I put all of function f in those parentheses. So it's going to be inside itself. 2x squared plus 3x, 2x squared plus 3x. Okay, so I took out the variables and I put the whole function in that spot. And then we simplify, and it's going to simplify really similar to part B now. Okay, so first thing I'm going to do is I'm going to FOIL. If I FOIL out 2x squared plus 3x, my first terms, 2x squared and 2x squared, are going to give me 4x to the 4th. My outside terms will be a 6x to the 3rd, and my inside terms will be a 6x to the 3rd. So that's a 12x to the 3rd. And then my last terms are 3x and 3x, so 9x squared. Plus 3 times 2x squared plus 3x. Then we distribute 8x to the 4th plus 24x to the 3rd plus 18x squared plus 6x squared plus 9x. And then we add together any like terms, which I just have 2 like terms. So my final answer is going to be 8x to the 4th, 24x to the 3rd, 24x squared, and 9x. Okay. The last one, letter D, is g of g. So I'm plugging g into itself. Now this one's not so messy because it's just a linear equation. I don't have like a quadratic, I'm not squaring anything. So I'm just going to write down function g, but I'm going to leave a blank where the x is at. So 2 parentheses minus 1. And then where that blank is, I'm going to put all of function g inside. 2x minus 1. 2x minus 1 inside of 2x minus 1. And then distribute and combine like terms. So 4x minus 2 minus 1. Final answer, 4x minus 3 for that one. Okay. Now on the homework, you will have to do the combination, the composition, and then you're also going to, on some of the problems, give the domain. So this was in the video yesterday, domain of the other ones, right? Okay, so I should have talked about, I think I did, we start by looking at the domain of the original function. Do f and g have any restrictions, any square roots, any denominators? No. So the domain of those is all real numbers, okay? And if there was a domain restriction, it would kind of carry throughout here, but there's not any, so we don't have to worry about that. look at all 4 of the answers I have here. Do any of those have any domain restrictions? No, so there's no restrictions in the original functions, f and g. There's no restrictions in the composition, so every single one of these would have a domain of all real numbers. And we always put our domains and our ranges in interval notation, negative infinity to infinity. Okay, so what I want you guys to do is I want you to find a friend or a group, and I want you to do these 4 compositions. Don't give the domain yet. We're going to talk about that together because there's going to be some restrictions on these ones, okay? But see if you can do the 4 compositions, okay? And if you're not sure how to simplify, just leave it, okay? And we'll simplify it together. But see if you can at least do the plugging one function, do another, and then we'll kind of see how it looks. So I'll give you maybe like, I don't know, 5-10 minutes to do these 4, and then we'll come back together, we'll check them, we'll talk about them, and we'll add the domains in. All right, go ahead. Okay. Let's see how you did. Again, there's no domains up here. This is just the combining part, okay? All right, so part A and part B, this is kind of a prelude into tomorrow's lesson, are inverses of each other. If you are actually, well, f and g are inverses of each other. If you're able to plug one function into the other and you get out x both times, it actually is a proof that they're inverses. Now, why does that happen here? When I plug f into g, it looks like this. The square root, the whole square root is squared, so I'm allowed to cancel that. And then the -3 and the +3 just cancel each other out and leave me with x. G into f looks like this. You really don't need the parentheses because there's nothing that's squared or multiplied. So if you get rid of the parentheses, you can just see that the +3 and the -3 cancel. Plus you leave me with the square root of x squared, which again is just x. Now f into f, you guys at this point cannot simplify something that looks like this, a square root under a square root. Now, if that -3 wasn't there, we could make it a 4th root of x minus 3 because there's 2 square roots. But because that extra -3 is there, we just leave it. Anything else with it. And then g into g looks more like the ones that we did on the previous slide, where you have a little bit of foiling to do here, and then you're combining your like terms together. Okay. What questions do you have on the compositions here? Okay, so now let's go back and look at domains. So I'm going to start with function g because that's the easier one. Does g have any domain restrictions? Does this guy have any restrictions? Remember, when we say restrictions, there's always 2 things that should pop in your head. A square root, a denominator. Are there either of those? No. Okay, so the domain of this guy is all real numbers. Is f going to have restrictions? Yes. So how do we find domain of a square root? Remember, we take what's underneath our square root, and it always needs to be what kind of number under a square root? Positive. So greater than or equal to 0. So x greater than or equal to 3, which if we put that in interval notation is 3 to infinity. Okay. So now f into g and g into f are just x. Are there any restrictions there? No, it's just x. But function f was used in both of those. So their domain is only 3 to infinity. Okay, because we already had restricted the original functions. I'm going to come back to f of f because that's a little crazy. G into g. Now, g into g only uses g. So I'm not even worried about f in this problem. G doesn't have any restrictions. G into g, that answer, doesn't have any restrictions. The answer to this guy is all real numbers, negative infinity to infinity. Okay. Now, f into f is tricky. Okay, we're not worried about g in this problem. We're just looking at f. We know at least the domain is 3 to infinity. But it's actually restricted a little bit more than that. For example, let's say you plug 3 into that equation. 3 minus 3 would give me a 0 under that first square root, which is 0. But then minus 3 would make it a negative number under the square root. So 3 is actually undefined. So I think the easiest way to do this, instead of getting like super complicated with how you solve for it, is figure out what's the first number that I could plug in here that would be defined. 3 doesn't work. 4 doesn't work. What's the first number that you could plug in that would give you an answer, not a negative under a square root? Think you got it? 12 is the first one that would work. And here's why. 12 minus 3 gives me 9. Square root of 9 is 3. 3 minus 3 would give me square root of 0, which is 0. And then anything bigger than that would ensure that I would have a positive number. So the domain here, you got to think about it a little bit. What am I allowed to plug in? 12 to infinity. That's a tricky one. Okay. Questions on those domains? All right, I just got one more slide for you. You guys will have a little time to work on homework. Okay, this is a kind of abbreviated version of something you're going to see on Math Excel. So Math Excel is going to tell you, I've got this function h. I put two functions together to get function h. We're going to work backwards. Can you tell me two functions that if I plug one into the other, this would be my answer? Okay, and they're going to ask you in a certain way. They're going to say f of g of x equals h of x, which means if I'm looking at that notation, I want to ensure that if I plug g into f, I get h. That's what that statement means. Okay, now let me give you an example. If I'm looking at this absolute value equation, the first one, I need to write two functions, f and g are going to make up my answer. My goal is to figure out two equations that if I plugged g into f, I would get that out as an answer. There are a lot of ways to do this. Some are easier than others. I would do this. I would make f the absolute value function, and I would make g 3x plus 2, what's inside it. Because that's what I'm doing when I'm composing. I'm putting one thing inside the other, right? Do you guys see that if I took 3x plus 2 and plugged it into that absolute value, I would get h out? Okay, here's another way to do it. I could make f of x the absolute value of x plus 2, and I could make g of x 3x. I could take 3x and replace the x with it, and again, I would get function h. Make sense? Now, when you do it in Math Excel, it's going to be multiple choice, and you're going to choose the one pair that works because there really are an infinite number of answers to these. Okay, see if you can, with a friend, find two functions for these ones at the bottom. Okay, so find an f and a g that if you plug g into f, you will get this function out as an answer. And again, there's lots of different ways to do it. Okay, see what you can do. So we have x in both equations. This one. We good? All right, here's what I would do. I would make f 5 over x and make g x minus 4. So again, needs to be an x in both your equations. That's what makes it a function, right? We got our variables there, not a constant function. So I'm taking that x out, putting x minus 4 in its place. For the bottom one, I would say f is the 4th root of x, and I would say g is just all that stuff that's inside of it. So you can see I'm kind of working backwards and figuring out what's the big picture and then what was plugged inside it to get those two pieces. Now, you could, if it's not multiple choice, if you're making your own up, actually make your life really easy for these problems. I could, for any of these problems, and maybe a couple of you saw this, make function g just x and make function f the same thing as h. Did anybody see that? Because I'm just replacing an x with an x and it works. So I could do that for this one. I could make it like fourth root of all this junk. And then x is my function g. That would work every time. Now in Math Excel, it's going to be multiple choice, and that will not be one of the choices. But you could do that. Okay, so this is called decomposing. When we have a composition and we're breaking it apart into pieces. All right, that is it for our 2-8 lesson. So Math Excel is due on Thursday night. I will tell you guys, you're not going to love me on this Math Excel because problems have multiple parts. Like you're going to see two functions and you're going to have to add, subtract, multiply, and divide. Do not wait until Thursday night to do this Math Excel. Give yourself like 5 problems a night or 6 problems a night, and it's not going to seem so overwhelming. But like I said, Thursday will be a work day in class too to help you get some time to work on it, okay? All right, so we're going to do 2-9 tomorrow. And then that's the last new lesson for the week that we got to worry about. That's actually the last lesson of the chapter 2. So next week we'll be getting ready for our next test and all that good stuff. All right. Cell phone